Example 1. Use the addition rule in order to find the probability of f or b. Now, every time we're trying to find a probability, we know that we're trying to get the ratio of the number of possible outcomes divided by the sample space. So here, I'm going to begin this problem by first calculating the sample space, because we're going to need to divide by the sample space. So here we're going to add every number that we see inside this Venn diagram. So we see 32, a 44, and a 24. And when we add them all together, we're going to get 100. So that's the sample space. Okay, now let's try and see the number of possible outcomes. So here we're trying to get the probability of f or v, and we see here that there is no intersection. If we look back at our notes, we can see that that's an example of two events that are mutually exclusive. So to calculate the probability of an or problem, we can simply do so by adding both probabilities together. So here I'm actually going to write the skeleton. So my skeleton here is probability of A or B equal to the probability of A plus the probability of B. I don't need to subtract the intersection because no intersection exists. And now I'm gonna substitute. So for my problem, I don't have A or B. I have F or V. So this is gonna equal the probability of F plus the probability of V. Now, the probability of f, that's the number of fruits. So here I get 32 over my sample space, which is 100, and I'm going to add that by the probability of v, or the probability of veggies, and veggies is 44 out of 100. So I add them together and I'm going to get a 76 out of 100. That's the ratio, the percentage. You can input it in the calculator, or you can do it mentally if you're good with fractions. So here we're going to get 76%. Alright, let's take a look at one more example. So here it says, given the probability of t or b equaling 24, we have to use this information in order to find the probability of t. So this problem is a bit different, but we're going to be using similar strategies. The first thing to notice about this problem is that here we do have an intersection. And here that's going to be 6. So since we have an intersection, we can see that we're going to be using this version of the addition rule, where we will have to subtract the probability of A and B. So let's go ahead and map that out. So I'm going to actually write the formula as my skeleton. Probability of A or B equals the probability of A plus the probability of B, and we're going to subtract the intersection. So now we have to find those three probabilities and just plug and chug. Let's begin by finding the sample space here. Let's check out one more example. So example 2, find the probability of t or b, then use the addition rule in order to verify your answer. So here's how I want you to do these problems. First, we can find the probability of t or b by using the information we learned from the previous lesson. And every time you're trying to find the probability, you know that you will need the sample space. So let's get that out of the way. So the sample space, we add every number that we see. So here we have an 11, a 6, a 7, and another 6. So let's go ahead and add those four numbers together. 11 plus 6 plus 7 plus 6. When we add them, we're going to get a total of 30. So our sample space is 30. So let me rewrite this here. Sample space equals 30. Okay, so now we can find the probability of t or b. So the probability of t or b, we know that that's going to get divided by 30. So now let's find the numerator by first counting all of the possibilities for t. So here we see that t, when we highlight it, we have an 11 plus a 6. And now if we want to include b, we gotta add these remaining 7. And the probability of t or b is gonna equal 24. 24 over 30. And now let's input this in a calculator so we can get the percentage. And we get a total of 80%. So we found the probability by using the knowledge from a previous lesson. Now we're going to verify that our answer is indeed 80% by using the addition rule that we learned yesterday and today. So if we take a look at our notes, we see that we're now in this situation where the events are not mutually exclusive because we have an intersection. The probability of A and B is not equal to 0. In our example, it's equal to 6. Okay, so that means we're going to have to use this version of the addition rule. So let's verify it. Let me write my skeleton. Probability of A or B is equal to the probability of A plus the probability of B minus the intersection probability A and B. So that is the general formula. Now we're going to apply it using these variables, t or b. So let's plug in chug. We don't have a and or b, we have t or b. Probability of t or b is equal to the probability of t plus the probability of b minus the probability of t and b. So here the probability of t is going to be, for the probability of t, we count the possibilities of t. So let me shade that so you can visualize this. So everything inside of b is basically 11 plus 6, and 11 plus 6, that's a total of 17 over the sample space of 30. And now we're going to add the probability of b. So let me clear what I shaded right now. And now to get the probability of b, we're going to count everything that's inside of b. So let me shade b. And we have a 6 plus a 7. And 6 plus 7 is 13. So the probability of b is 13 out of 30. And you can notice that I technically included this 6 twice, which is right. I'm going to have to subtract it once here. So let's subtract the intersection. And here the probability of t and b, let me go ahead and emphasize that part. That's this intersection. That's 6 out of sample space, which is 30. We're dealing with probabilities here. So now we add these fractions. We have a common denominator, which means that we can add the numerators. So 17 plus 13, that is going to be a total of 24 over 30. Whoa. So 17 plus 13 is 30 over 30. And then we subtract the 6 over 30. So 30 minus 6, that's going to be 24 over 30. And this basically verifies that we do get 80%. 24 over 30 is 80%. Alright, so basically this is how I want you to verify your answer using the addition rule. So try out the next problems, practice your substitution, practice your algebra. If you have any questions, like always, feel free to email me, message me, or join me during Zoom office hours. See you next lesson.